and welcome. I'm Dave. Today we'll learn about TypeScript classes, implementing interfaces, and much more. I'll provide links to example source code and all resources in the description below. I've also recently started a Discord server, and I've provided a link for you to join in the description below. It's a great place to post any questions you have about this video and to chat with other web development students too. Our starter code today is the code from lesson 5. This is lesson 6. I'm just going to select all with Control A, hit backspace to delete all of the code we have in the main.ts file. I'll save that. I'd also like to highlight that we have the index.html file inside of the build directory, and I've changed this from the last tutorial because we had an example there. Now I've just got it back to looking for the main.js file that will be compiled and saved into the JS folder here, and it just is named example. So that previous code in the index.html is gone. Okay, we're talking about classes today, and we've got a lot to cover. So let's look at a basic class. I'll just say class, and we'll call it coder. And then inside of the class, properties and methods are called members. So I'll put a member for the class, and this is a property called name, and I'll say it's a string type. You can see that TypeScript doesn't like this. Let's see what's wrong when we mouse over. It says the property name has no initializer and is not definitely assigned in the constructor. So we do need a constructor. So I'll go ahead and start with a constructor here. And then we want to say this is name and it's a string, which is kind of redundant, isn't it? And then inside of there, we're going to have this dot name, and we'll set it equal to name. So when we look at this, we think, how could we make this simpler? And we'll talk about that in a second. But first, if we don't have the constructor, TypeScript didn't like what we had up here. So if I just remove that, because it appears to all be right here, I'll use Control X to cut it out. TypeScript still doesn't like this. Now when I mouse over, it says property name does not exist on typecoder. So even though it seems redundant, this is actually what we need. Now we will look at another way to do this in a moment, but I just wanted to give the basic structure here that you do need the property to exist in the class as a member, and then you also need to name it here in the constructor. Okay, now let's take this example a little further. So after our name, which is a string type, let's put in music as another property that is a member, and we'll say it's also string. And then let's put in age, and that will be a number. And finally, let's put in lang, and that will be a string, and that's abbreviation for language is what we're going to put there. Okay, after we've done that, we need to add all of these. You can see we have red squigglies for each of those, so we need to do the same here. So we'll say music is a string, and age is a number, and finally lang is once again a string. Now, it might be easier to read if you had more of these if you just break them out onto separate lines, and we can do that. We put a comma after each one in the constructor parameters here, and then I'll put the parentheses on the following line. I'll go ahead and save just to get some formatting. You can see TypeScript still says we need to do more, and that's because we also need this dot name to equal name, which we have, but we need to do the same for the others. I'm going to do Shift Alt and the down arrow 3 times, and after I've done that, I can select name, Control D to select name twice, and change this to music. And I'll do the same for age, and finally, I'll do the same for lang. Well, I didn't select the second one here. Let me try that again. There we go. So this does seem very redundant, but here we do now have our structure. We have added all of these members to our class, and then the constructor accepts those as parameters because they could be passed in when we instantiate the class, and that's why they're here as parameters. And then we actually assign the values. Now for me, I really like to keep things dry. I don't like all of this redundancy. And fortunately, there is a way to avoid this. Now we can add what are called visibility modifiers. I've also heard these referred to as data modifiers or even access modifiers, but the official docs say visibility modifiers or visibility members. So let's go ahead and put that here. By default, all of these properties, and if we had any methods, would be public. But right now, we don't have to say that, but we can explicitly say they are public. So I could put public in front of name, but you can see now it doesn't like what we have. Now it says it's a duplicate. And that means we can just remove the one up here. Now TypeScript's happy again. So if we go ahead and add these visibility modifiers to each of these in the constructor params, then we don't need these up here. So let's look at what else is available to us. We could have music, and besides public, we also have the option to make this read only. You know what I think I'm going to do? Of course, I need to remove this up here. I'll just remove all three so I don't have to keep going back. I think I'm going to go ahead and make music public, but then I'll make this actually public and read only, because you can do both. So that means once the name is assigned, it cannot be changed. And then of course, this is explicitly public as well. When we talk about the music type, let's make age private. And that means it can only be accessed in the class. And we'll look at an example of that as well. And then let's make the language protected, and that is our last option there. So we're looking at all of these different modifiers onto our data, but this makes it a little less repetitive. Our code is a little more dry. So even if you just use the default of public, you won't have to type it twice if you do it this way. Now, before I go further with these modifiers, I do want to show one way to avoid those errors. It would be very unusual, but say you were adding a property that you did not want to instantiate right away. Maybe a third-party library or something like that is handling some of this for you. Either way, I just want to show an example of how you could do this. So I'm going to say, let's just say second language, second lang, and we could say string. And then you're going to, of course, see this red squiggly, and it's going to say it has no initializer. But we can add an assertion here, and this means that we are asserting that we know what we're doing, and we're just not going to initialize this right away. So you can add this if necessary. Again, beginners, I recommend staying away from this, but it could come up sometime in the future, and it would be a nice thing to remember. Okay, I'm going to save our class, and then underneath this, we can instantiate it. So I'll just say const, and I'll say Dave will be an instance of our coder object. Set this equal to a new coder, and inside I'm going to pass in the name argument, and then we need a music argument, let's say rock, and then we need an age argument, and I'm going to say 42, not that it's my age, but hello Douglas Adams, if you're familiar with his books. And now we can add our final param, and this would be, say, TypeScript. But what if we want to make this optional? Well, we can do that because constructors are a lot like passing params to functions. So instead of providing TypeScript here, let's make the last one, language, optional by adding a default value here. So we can just say this is TypeScript. And now you can see TypeScript is fine with me creating a new instance of coder named Dave without providing that fourth parameter. And now remember, age is private. First, name and music are both public, even though name is read-only, and lang is protected. Now, what's the difference between private and protected? Well, it can be accessed, or I should say lang can be accessed inside of the class, but it could also be accessed inside of derived classes. If we were to extend this to a subclass, we could still access lang, but we could not access age because it's private and can only be accessed inside of this class. So I'm going to scroll up and add a method here, and I'll make the method public, and I'll just say get age. Remember, age is private. Inside the method, we'll just say return, and we'll give a template literal here that says hello, and now let's say this dot age, which should retrieve the age. This is fine because we're inside of the class. So even though age is private, we can access this value inside of the class, and we can just call the getAge method to, of course, return that value. However, let's look at what TypeScript knows about our class, and we could say, let's do console.log. I'll say dave.getAge, and it should be fine with that, and it is. But what if I had console log, and now I say Dave, and I just try to access the property, the member of the class, age? It doesn't like that. It says age is private and only accessible within the class coder. So we can't do it that way. Likewise, I'll copy this down with Shift, Alt, and the down arrow, And let's try to access lang. And again, TypeScript says no. I mouse over and you can see property lang is protected and is only accessible within the class coder and its subclasses. So while we can access a method that accesses the age value inside of the class, we can't access those properties directly outside of the class. I'm going to go ahead and save our TypeScript file and then press Control and the back tick to open up a terminal window. Type TSC and -W for watch so it compiles. And I've got a couple of errors, of course, that we put in there on purpose, but we have compiled that now. So let's go to our index.html, and I'm going to use live server to launch that. And you can see it launched here on the left. I'll drag Visual Studio Code over to the left window as well. Back to our main TS file, and then Control B to hide the file tree. I'll click on the browser and I'm going to press Control Shift and the letter I to open up DevTools, and we have the console here. So I'm just going to drag this up and we can see, of course, ignore the live reload enabled, or I can just clear this out and I can refresh the page and we get hello, I'm 42, which is get age, and then we get 42 in TypeScript. So remember, we're going ahead and compiling this, and even though TypeScript, the compiler, doesn't like what we're doing, it is still legal JavaScript, so TypeScript lets the page go ahead and compile. And of course, we could change that in our settings so it would not compile if it didn't like anything, but it lets you gradually adjust your code and refactor your code to TypeScript. So it is working, and it shows the 42 in TypeScript, even though it doesn't like that here. I'm going to go ahead and comment out these two lines that TypeScript doesn't like, but I'll leave them in here just so you could uncomment them and see those in the source code if you download it from the course resources that are linked in the description. Okay, after that, let's go ahead and extend a class. So I'm going to create another class. I'll call this class WebDev, and I'll say extends coder. And then inside of this class, we should have a constructor. And then, of course, we'll have our curly braces as well. We need to pass several things into the constructor, but I'm going to add a new property also. So I'm going to say public and put computer, and this will be a string. I'll put a comma because underneath this, we need to add what we're bringing in as well from coder that we extended. And I'm just going to bring in name, age, and number. So I'm not going to bring in the language that has a default value already. And then when you extend a class like this, before you assign anything here, such as this.computer equals computer, which is what we would do, we need to put something in front of that. And if you're familiar with JavaScript classes, as you can see, TypeScript wants to help us. We must put in a call to super. So let's put in our super. And then it needs to receive everything that we are receiving from coder. So it will get name, music, and age. So again, remember, super here needs to come before we try to assign anything else like this.computer. So if I put that above, TypeScript is not happy. So I'm going to undo that and make sure that assignment is after the call to super. And now notice we did not bring in the lang member that we had above in coder, but we extended coder here, and lang has a default value of TypeScript. So let's go ahead and add a method here, and we'll say public and then get lang, and we'll return a template literal, and I'll say I write. Now let's put in this.lang, and let's see what happens when we call this after we instantiate a web dev. So I will come down below this and I'll say const, let's call this instance Sarah, put this equal to a new web dev, and the computer is first. So we'll say Sarah has a Mac, or Sarah's name is Sarah, and she listens to lo-fi, and put in an age of 25. And you can see TypeScript is now happy. We have passed in all the params that we needed to for the constructor. So now that we have done that, let's go ahead and say console.log and call sarah.getLang. And when we save, it should recompile. And yes, remember we commented out a couple of lines. So we have the get age up here says, hello, I'm 42, but below we had Sarah get Lang, and it says, I write TypeScript. So notice how we didn't put any of those modifiers on name, music, or age here. So what about accessing those now? Will they be public by default? Let's find out. I'll type Sarah, and then let's try to access age. But TypeScript says, no, age is still private, and it's only accessible within the class coder. So let's go ahead and try to access the protected property, because that can come down to subclasses, right? So our protected property was Lang, if I remember right. Let me scroll up and look. Yes, protected Lang in our coder constructor. So let's switch this to Lang, because now we have a subclass. Whoa, it still doesn't like that, does it? We mouse over, it says property Lang is protected and only accessible within the class coder and its subclasses. Note here, even though this is a subclass, we're not within the class. But this is a subclass here, our WebDev extends coder, and within the class, we could access the protected Lang member, the property from the coder above that we extended to WebDev. I'm going to comment out the two things that TypeScript did not like again here, and let's move on to the next example. And I'll put a little bit of a line here in the code as well. Let's see if we can just leave that in. Yes, and that will just draw a dividing line, because now I want to talk about applying an interface to a class, where you could say implementing an interface to a class. So I'm going to create an interface named musician, and we have looked at interfaces before as we covered objects in this series. I'll give this interface several properties, a name, which is string, and then let's say instrument, which is also a string. And now let's give a method. We'll say play, that's going to receive an action, which is a string, and it's going to return a string. So a simple interface with two properties, one method. Now we can implement this to a class. So I'll scroll up a little bit more. And then after this, we'll say class, and we'll make this a guitarist. And we'll say implements with the keyword implements. And then we'll say musician. So we name the interface. Now inside of this, guitarist already has a red squiggly line, so we can see what it wants. It says it's missing the following properties from type musician: name, instrument, and play. It's going to need all of those. So I'll say name, and that will be string. And we'll have an instrument, which is a string. And now let's go ahead and provide the constructor. And I'm taking the long way on this one, but that's okay. We'll put inside of this, we need to say name, actually string, and we'll have instrument. That's a string. Much more than that, and I would have broken those onto separate lines. After that, I'll say this dot name equals name, and this dot instrument equals instrument. Nice review there of everything. But guitarist still isn't happy because it still needs play. So we haven't put the method in yet. So let's do that. And we'll say play. And then we'll have our action, and it's going to be a string. And then we're going to return a string. So I'll say return and do a template literal. And this is going to be this dot name. So whatever name is passed in. And then we'll go ahead and say whatever action is passed in. And after that, we'll say the, and then we'll say this dot instrument. So this should return a sentence that reads something like Eddie strums the guitar, or something like that. So here we have our class that implemented our interface. And notice if we switch name to number, it's going to check against that interface. And it says property name in type guitarist is not assignable to the same property in the base type musician. So these do need to match up. So we'll say a string, and then it once again matches. So TypeScript implemented our interface, musician. It made sure all of the members of the class were there as expected, and it's even checking the types back to, of course, musician here that we defined in the interface. So we've got all of that. Let's go ahead and instantiate one of these guitarists. So we'll say const, and I'll say Page. Let's do that one. You know who Page is. We'll say new guitarist, and here he is, Jimmy Page. If I could spell Jimmy correctly, and yes, he has a guitar for an instrument, which kind of makes sense. That's a kind of a duh moment, isn't it? After that, let's go ahead and say console.log, and then we'll say page.plays, and we're going to say strums for the action. And this is a good example because TypeScript caught my mistake. I said plays. I wanted to say page plays the guitar, but play is the method, not plays. So if I remove that S, now it's accurate. I can save, and we get Jimmy strums the guitar over in our console. I'm going to scroll for some more room and once again put in a divider in the code because we are switching topics, although we're still talking about classes. I'm going to create a new class here and just call this peeps. Inside of the class, we're going to create a static member, which would be a property here. So we'll say static, and this would be count, and count is a number. I'm going to set it equal to 0. And then I'm also going to create a static method that is also a member of the class. So I'll call this getCount, and it's going to return a number. And then we'll return, notice what I do here. I don't use the keyword this. I refer to the class itself, peeps.count. So what a static keyword does, it means that count does not apply to any instantiation of the class. It applies to the class directly itself. So we'll be keeping track of count in the class, not in any one instance of the class. And then getCount can be called directly on the class as well. And so that's why I'm accessing count directly on the class peeps here. Now let's go ahead and give a public property. So I'll say public, and we'll create an ID, and this will be a number type. And after that, we'll use a constructor, and we'll say public here as well, and we'll receive a name param, and this will be a string. And then inside of the constructor, we'll say this.name is equal to name. And then we're also going to say this.id that we used above is equal to ++ peeps.count. So what does the ++ do when you see it on the left versus the right? Well, it's going to make sure that our count increments first. So what we're going to have is an ID of 1 instead of an ID of 0 when the first instantiation of this class is created. And you'll see how this works. And this is just normal JavaScript here. We're not saying anything specific about TypeScript, but if I put the ++ over here, our first ID would be 0. So I'm putting the ++ way back over here on the left. So our first ID is 1. Okay, so now I'll scroll up and we'll instantiate peeps for a few people. So let's say const John. I'll set him equal to new peeps, and I'll pass in John. And then I'm just going to Shift Alt and the down arrow a couple of times. Select John here, Control D to select the second John, and of course make a Steve, and then do the same thing here, and let's make an Amy. So now we've got 3 instances of peeps, and we've created John, Steve, and Amy. So let's log some things to the console. First of all, let's console log our peeps count. And this should tell us how many times the class has been instantiated to create objects. So let's see what we get. We get 3. So we've created 3. If I remove Amy, just Control X and then Control S to save, we get 2. So we're incrementing our count on the class peeps for every object that is instantiated from it. That's kind of cool. What about the IDs? So let's go ahead and say console.log, and let's get the ID from Steve. So what is his ID? He's created second, and that's what we get. We get the 2. Of course, we had peeps count 3 at the bottom. We get 2. Let's get Amy's count. So console log, and we'll say, or I said count, let's get Amy's ID. Her ID is 3 because she was created third. And so you would expect John to have an ID of 1. Let's take a look. John.id and save. Yep, John's ID is 1. So the main thing to take away here with using the static keyword, of course, is that it applies directly to the class and not to any specific object that you instantiate with the class. Okay, one more example. I know we've covered a lot, but let's fit in something about getters and setters, because you might see this in React when you're used to working with the useState hook, for example, or you're just wanting to keep state in an object you instantiate. So let's go ahead and create something like that. Let's say class, and I'll say bands here. And then I'm going to set a private member, and I'll call it data state. This will be our state that we're keeping track of in bands, and it's going to be a array with string data. Okay, after that, I'll say constructor, and we're not going to pass anything in, but this data state can get initialized as an empty array, and that's fine. After that, let's put some methods, and we can put public or private on any method too. So I'll say public, I'll say get, which is a keyword, and I'll say data, and then after that, I want to say this getter is going to return an array that has string data in it. And that's exactly what we're going to return, because we're going to return our state, which is this data state. Now, if I just leave it as this, that makes this read-only because there is no setter. But get is a special keyword that we can use in JavaScript. Again, this isn't just TypeScript, but in JavaScript, to get our data that we have inside of our state here that is private right here. So being read-only, I would want to initialize this with some more data here. But just to keep moving, let's go ahead and create our setter as well. And set is another special keyword that we're going to use. And we'll use data once again. Now I'll say value is an array full of strings. So that's what it should accept. Now let's think about what we want to do to check to make sure this data is correct inside of our setter. So I'm going to say this needs to be an array full of strings, and we can check that by saying if array.isArray, and then we can pass in the value. So that checks to make sure it's an array. How about checking to make sure every value is indeed a string inside? And I just gave the keyword there. We can say value.every, which is a method that you can call on an array, a higher order function, if you will. And then let's say for every element, we're going to check type of element, and we'll make sure it is equal to string. So this would be true or false is what every would return after it checks every element, and every element needs to match that in order for every to return true. So now that we have checked everything we need to, we can say this data state equals value, and then we can return. I'll look at this return in just a second to see what else it might do, but let's also say here else throw new error. And we can be specific here. We could say param is not an array of strings. Okay, coming back to this return, I put it on this line here, but what if we tried to just return right here to end this out? Now, TypeScript doesn't like that. Let's look at why. It says setters, specifically setters, cannot return a value. So I'm going to undo this. The empty return is okay, but setters cannot return a value. And let's see how TypeScript identifies this. So if I mouse over data, it says it's a setter. And we're going to set the bands.data, and it should be an array full of strings. And likewise, if I mouse over data up here, this is a getter, and it's bands.data, and it should return an array full of strings. So let's check some of this out by instantiating one. I'll say const, and here I'll say my bands. And I'll set this equal to a new bands. Now I'll say my bands.data. And here I'll put an array, and we'll say Neil Young, some good classic rock maybe, Led Zeppelin. So I'll just say Led Zepp. And then underneath that, we'll say console.log, and I'm going to log my bands.data. That's how you use the getter right there, is just to say .data. So let's save and see what we get. We've got an array. It returned the data. Neil Young and Led Zepp is in the array. So after that, let's use the setter. So here I'll say my bands.data once again, and I'm going to set it equal to an array once again, and I'm going to spread in my bands.data that we already had because we used the setter right here. My bands.data equals uses the setter. So we've already got that in there. I want to add one more band. I'm going to add ZZ top. Okay, now that we've done that, let's just copy this line down again so we can use the getter to get that data once again. And when we save, now we've got an array with Neil Young, Led Zepp, and ZZ Top. So what about that error we put in there? We were checking some things to see if it received the correct data when we attempted to set it. So let's try to use that setter again. We'll say mybands.data equals Van Halen. Look, TypeScript knows. It says this is no good. String's not assignable to the type array that should have string data. That's not going to work. So let's go ahead and make it an array. And I can do that by putting the brackets around it. Now that would work. But what if we had the string Van Halen in and the second element was 5150? Once again, TypeScript says no go. Number is not assignable to type string. So everything is working there. But we didn't actually go ahead and save this to see if it would throw an error as well. So let's do that. We save. Yep, param is not an array of strings. So we coded our check up here correctly, and we're throwing our custom error right here because we didn't meet this criteria. Likewise, if we switch that back to just a string like Van Halen, it would also throw that error. Remember to keep striving for progress over perfection. And a little progress every day will go a very long way. Please give this video a like if it's helped you. And thank you for watching and subscribing. You're helping my channel grow. Have a great day, and let's write more code together very soon.